There's a place on Earth where the laws of biology seem to break down, where eyes grow to the size of dinner plates or disappear entirely, where fish carry lanterns made of living light, where jaws unhinge wide enough to swallow prey twice their own size. It's not another planet. It's not science fiction. It's 3 kilometers beneath the surface of the ocean you've seen 1,000 times. And the deeper you go, the more the rules change. This is the story of what happens when life is pushed to its absolute limit, when survival demands transformation so extreme, so utterly alien, that the creatures living there barely resemble anything we recognize as life at all. This is why the deep sea turns animals into monsters. Imagine you're falling through darkness, not the darkness of night, something older, something absolute. You pass 200 meters. This is where sunlight gives up, where photosynthesis becomes impossible, where the color blue is the last thing visible light can produce before it surrenders entirely. The ocean calls this the twilight zone, but twilight suggests a horizon, suggests something beyond. Here, there is no beyond. There is only down. At 1,000 meters, the pressure is 100 times what you feel at the surface, enough to crush a human skull like an eggshell. The temperature hovers just above freezing. There is no food raining down from above, not enough to sustain the kind of life you know. And yet, life is here, but it doesn't look like life should. The first creatures you encounter seem assembled from nightmares. The viperfish, with fangs so long it cannot fully close its mouth. The gulper eel, a living sock with jaws that open wider than its entire body. The bear-eye fish, a transparent head, its eyes gazing upward through its own skull, like twin green orbs suspended in glass. These aren't monsters, they're solutions, because every bizarre feature, every grotesque adaptation is an answer to a single question. How do you survive where survival should be impossible? The deep sea doesn't create monsters. It reveals what life becomes when Earth stops being gentle.
In total darkness, evolution does something extraordinary. It invents light. More than 90% of deep-sea creatures produce bioluminescence, a cold chemical fire made by living cells. They don't do it for beauty. They do it because light, down here, is power. The anglerfish dangles a glowing lure above its head, a fishing rod grown from its own body. The light comes from bacteria, millions of them living in a bulb of flesh, farming light in exchange for shelter. When prey investigates, the anglerfish's jaw snaps shut in 6 milliseconds, one of the fastest strikes in the animal kingdom. But here's the twist. In the deep sea, predator and prey both glow, so bioluminescence becomes an arms race. Some creatures flash to startle, others glow to camouflage, producing light on their bellies to match the faint shimmer above, erasing their silhouette. It's called counter-illumination, invisibility through light. And then there are the eyes. In the twilight zone, eyes grow enormous. The giant squid's eye is the size of a basketball, the largest eye on Earth, not for seeing detail, for collecting every last photon, for detecting the faintest glow of a predator moving through the black. But deeper still, eyes start to vanish. Below 2,000 meters, many species are born without them. Vision becomes a liability, a complex organ that costs energy, attracts parasites, and offers nothing in a place where even bioluminescence fades. So evolution does the math and erases the eye entirely. What's left are creatures navigating by pressure, by chemical trails, by senses we don't have names for. Scientists still don't fully understand how some of these animals perceive their world. They're studying fish with no eyes that somehow avoid obstacles, detect motion, react to threats. It's as if the deep sea has developed its own language, and we're only beginning to translate. Food is scarce in the deep sea. Not just rare, almost non-existent. The ocean floor at 4,000 meters receives about 1 calorie per square meter per day. For reference, a single human needs about 2,000 calories. Imagine trying to survive on the energy equivalent of a postage stamp. So, evolution builds creatures that can wait. Some deep-sea fish have metabolism so slow they barely qualify as alive. Their heart rates drop to single digits per minute. They hover motionless for weeks, conserving every molecule of ATP, waiting for something, anything, to drift within striking range. And when it does, they don't let go. The black swallower has a stomach that can stretch to 10 times its original size. It can eat fish larger than itself, their bodies visible through its translucent skin, dissolving slowly over weeks. The fangtooth fish has the longest teeth relative to body size of any animal on Earth. They don't chew, they impale. And then there's the most alien strategy of all, sexual parasitism. Male anglerfish are born as little more than swimming noses, designed to find a female by scent alone. When they do, they bite into her flesh and fuse permanently. Their circulatory systems merge. The male's body atrophies, his eyes, his organs, everything except his testes, until he's nothing more than a genetic appendage, a living sperm bank fused to her for life. It sounds grotesque, but in an ocean where finding a mate might be a once-in-a-lifetime event, it's genius. This raises a larger question, though. If life in the deep sea is so difficult, so extreme, so hostile to existence, why is there so much of it? Scientists estimate there are more fish living in the deep ocean than in all surface waters combined, more biomass in the darkness than in the light. We've only explored 5% of the ocean floor, which means 95% remains unknown. And in that unknown, there are creatures we've never seen, adaptations we haven't imagined, monsters we haven't met yet. Below 6,000 meters, you enter the Hadal Zone, named after Hades, the underworld. This is the deepest place on Earth. Trenches so profound that if you dropped Mount Everest into the Mariana Trench, its peak would still be underwater by more than a mile. The pressure here is over 1,000 atmospheres, 8 tons per square inch, enough to collapse submarines, compress air pockets, fold metal. And still, life is here. Snailfish, translucent and ghostly, swimming at depths where their bodies should implode. Amphipods the size of dinner plates, crustaceans that grow enormous in the cold and pressure, microbes that survive on chemicals seeping from the Earth's crust, in ecosystems that don't rely on the sun at all. These creatures aren't adapted to the deep sea. They're built from it. Their cells contain molecules we're only beginning to study, proteins that stabilize under crushing pressure, membranes that function in near-freezing water. Some scientists believe these adaptations could hold clues to how life first emerged on Earth billions of years ago in conditions just as hostile. Others think they might show us what life looks like on other worlds. Because if life can survive here, in darkness, in cold, in pressure that would obliterate us, then the deep sea isn't just a habitat, it's a test, a proof of concept, that life doesn't need light, doesn't need warmth, doesn't need comfort. It only needs a crack in the armor of impossibility, and it will find a way through. We like to imagine we know Earth. We've mapped its continents, climbed its mountains, named its rivers, but we live on the surface of a water world, and we've barely looked beneath. The deep sea covers more than half the planet. It contains 95% of the biosphere, and we know less about it than we know about the surface of Mars. Every time we send a submersible down, we find something that shouldn't exist. Fish with antifreeze in their blood, worms that live inside methane ice, octopuses that brood their eggs for 4.5 years, the longest pregnancy of any animal on Earth, hovering over them in the dark, starving, waiting.